Well, good morning, everyone. Thanks very much, of course, for attending JUC, and thanks for coming to my session. My name's Andrew Phillips. I'm going to be talking today about optimizing automated testing with everyone's favorite Butler. In fact, if you want to know the story of how Jenkins came to be Jenkins, it's a funny question to ask Kosuke. He has a very nice story about where the name came from. In order to set expectations here a little bit, you could also rephrase the talk as how to structure and manage your tests if you're looking to move towards accelerated or continuous delivery or something along those lines. And what that implies a little bit is that Jenkins will do some of the work, but it will not do all the magic. So we're going to spend quite a bit of time talking about, if you like, foundations about how you structure your tests and some of the challenges that come with that, and then how you leverage that foundation from Jenkins. So just to give you a kind of idea of what we're getting ourselves into. But first, let's just to get a kind of a feel for the room here. Who's running tests from Jenkins right now? Okay, okay. Good, come to the right session, I hope. I hope I'll teach you something. Who's running tests from more than, say, 5, or well, let's say 3 different types of test tools in their pipeline? That's a smaller number. Okay, so I think you'll start to see maybe some of the challenges that we're going to be talking about and trying to address. Who's running into problems that there's actually too many tests to run, that they either take too long or they break or whatever to do it all the time? Oh, there we go. Okay, so yeah, again. So for those people at least who just raised their hand, we should have some interesting kind of food for thought. I'll also give you an advance warning that there aren't perfect answers to everything. So some of the stuff I'm going to showcase at the end when we look at a couple of case studies are homebrew-ish solutions to particular problems for which, as far as I know at any rate, there are no great opportunities or challenge, or rather solutions right now. So having said that, it's going to be, because I'm a bit of a walker normally, I'll be running up and down. Now because I've got this mic here, I'll be stuck. So we'll see how I cope with that. Well, the things I'd like to discuss a little bit in the changes to what we're seeing in terms of how testing is done, and especially in relation to the overarching principle of we need to move faster, we need to be more efficient. I guess to a lot of you who just raised their hands, that won't be radically new, but I just want to set the stage. We're going to talk a little bit about the fact that what we're seeing more and more is that testing is a discipline, an automation discipline, and what kind of implications they have, or that has. I'm going to talk about 2 facets of continuous delivery, and then we're going to talk a little bit about some of the sort of the basics if you're going to set up tests in Jenkins, and then some things you can, or set up tests generally, and then some things you can do beyond that before touching on that final, potentially a bit unsolved problem about what to do with all the tests that you're getting. So first we get the me slide. You can come and ask me if you're really interested in what I do. Basically, I'm a developer by background. I'm now what is called, I guess, a PowerPoint developer, which is a bit of not a great, I guess I could call myself. I still try to keep my hands dirty, so I commit to a bunch of open source projects. I have some commits on some Jenkins plugins. I'm the VP of Apache JClouds, so I try to remember what it's like to actually do real work. I do a lot in the kind of microservice-y type space, which is also very much related to testing, because there it starts to become very critical, and I do a bunch of this kind of stuff, standing at conferences and hopefully being able to transmit some interesting information. My day job, so labs, we have a booth outside and a diagram that's almost impossible to read here, but that doesn't matter, you can come and ask me about it. Basically, we build a bunch of tools around DevOps and continuous delivery at scale. Some of them, we use all of them alongside Jenkins ourselves, and our users do that as well. I'm not here to go into too much detail about that. The one that comes closest to this topic is probably TestView, but again, this isn't a product pitch. If you want to see the product demo, come tomorrow. Here we're going to talk about some slightly more general things and the underlying principles. Okay, and the timing's going to be interesting. I'm going to try and leave some time for questions at the end. I've been asked to tell you that if you do have questions, don't be shy. There's this mic, because I guess we're going to record them, so you stand in a line behind the mic and you ask me a question, and then I come up with some excuse or something. We'll see. Anyway, so yeah, let's start out with this one. Nice PowerPoint animation, not designed by me. I'm not a big fan of those, but never mind. So most of what we're used to, or certainly what I'm used to as well from the kind of projects that I've worked on the background, is that if you look at the way test effort is distributed in your kind of build to release cycle, it's a little bit like this. There's this initial phase, you have an idea, you turn that into something that developers can potentially work on, and then you have this classic, okay, we need to structure the source code, or the object diagram or whatever, and then we need to actually write code, and then we start doing some testing. And a lot of that testing proceeds in the classic, we have different types of tests, and a lot of that is manual, or at least involves a bunch of manual work, even if the tooling that runs some of these tests is automated. And so this is a very backloaded type process. And of course, as we've learned over 20 years of horrific failure rates in software development projects, one of the reasons that we have problems is that because it's backloaded, it always ends up getting squeezed, and then we never do enough of it, and then we do find out that stuff breaks, but we don't have time to fix it, and so on and so forth. So I guess the big overarching trend for everything that we're seeing is move left, right? You've heard that phrase so many times: move testing left, move quality left, move whatever. And this is basically also what we're trying to talk about here. So the first movement that we're seeing a lot of as part of this is to move towards a kind of acceptance-driven testing approach, where instead of just focusing on technical technical attributes of the system, if I put in this, does this come out? We actually try to start thinking about the way we specify the system in some kind of automated or some kind of testable fashion that we can then use to verify. So this is a BDD style stuff, Cucumber or whatever, but the idea is that instead of having human written documents and then sort of translating them into technical language and then losing, the usual kind of knock-knock problem, that we start out with some of that. And then, of course, this design, build, test distinction is disappearing a little bit. There's more and more talk of, getting rid of the title of a test engineer and basically saying everybody who's working on the team is just a software engineer. Developers have just as much responsibility for designing, running, maintaining, and so on the tests as quote-unquote the testers do. This is basically a subset of the DevOps discussion, and those of you who follow that discussion, of course, every now and again there's a comment that it really should be called Dev Test Ops because there's many more people involved. And then, of course, the security group, but I need to be in there as well, but different discussion. Anyway, so development and testing is this distinction that we've had, and I'll come back on this one a little bit because I think there's also a cultural element to this, but that is disappearing a little bit, and part of that is also the way we manage tests, the tooling in which we specify them, the kind of style we use to do that. Integration and regression testing, of course, is still there, but we're moving towards a more and more automated approach to do this. This really should be stuff that just keeps running, and there's all kinds of paradigms about trying to sort of run them continuously and so on. They're still a little bit heavy. We'll talk a bit about some of that. And then, really, this is not, you can't move user acceptance to the beginning, but you can move the concept of thinking about how to model user acceptance into part of that BDD type thing to say, look, when we specify the system, we also want to think about and maybe even involve users. When would they think this is actually good enough? And can't we capture that right at the beginning of the cycle so that we can be confident earlier? So this is the classic fail fast idea, that what we're building actually works or will not work, instead of finding that out right at the end. So long story short, the pattern that we're seeing in terms of test effort is shifting left. That doesn't mean that we're doing less work in the integration regression phase, but that there's less manual effort involved here. Most of the actual human input in the testing cycle is co-located, and it's also done by the same people within the development and build phase. That's where you code up your tests. That's where you maintain them when they break. That's where you sit together with the test expert on your team to do all that kind of stuff. A good question somebody asked when we showed this diagram to a particular prospect is they said, so what about the area? Those who did calculus, what about the area under this line? Are you actually still doing the same amount of work? And potentially, yes. I mean, it's not so much that we're managing to make testing this magical, fully automated process. It's just that we move where this work happens and also move a little bit who does the work. And by doing that, we can try, because the people who are writing the code are also more involved in the testing, we can hopefully, either prevent problems from happening because there's a better understanding, and then also we have the safety net in place much earlier to make sure that things don't break. So yes, we still have people working on tests, but the actual, once they've written this test code, if we're trying to do this more and more often, it's going to be very hard if we rely to a large extent on manual testing. That doesn't mean, of course, that manual testing will fully disappear, like exploratory testing or some kinds of penetration testing. I mean, I've, as a vendor, we get this all the time. Oh, look, we ran some random test tool against, and it came up with these 800 results, and that's not penetration testing. That's just running some arbitrary set of security scripts, and sure, we can check all those boxes. But if you really want to make a system secure, you have to throw some serious creativity at it. So I'm not saying that manual testing will go away, but if we want to accelerate and move towards some kind of continuous delivery thing, we're going to have to embrace this idea that testing is an automation discipline. And that comes with a bunch of consequences. I've already said developers are becoming testers, testers are becoming developers. Of course, it also means that practices that we have in development, we are also going to apply to these tests. That works nowadays because a lot of the test tools we use, they have plain text files. It's stuff that you can check into a source code repository. It's not something that is some opaque binary that requires a fat client to open or something like that. But yeah, no, so you think about source code maintenance practices, and branching and versioning and ownership and structure, and we'll come back to structure quite a few times. But of course, also if you want to do this in an automated perspective, it starts to get very difficult if you're in that classic bottleneck situation. Well, there's only one environment we can test in. And then, yeah, well, some other team, they just screwed it up by reconfiguring the CLR or the JVM or whatever. And now you waste half your test time trying to get the server up and running again. Yeah, that's not going to help us if we're trying to move more quickly. So the good thing is, I mean, we're at a Jenkins event, but the last 5 years has seen an enormous growth in cloud, containers, DevOps, all that kind of technology. And that really provides the foundation. And a lot of the vendors out there, that's exactly what they're selling. The idea that you can spin up your process, your testing setup, your environments, getting your test data in a much more on-demand fashion so that you're ready to run your tests whenever you need to. And a lot of that uses this infrastructure as code stuff. So there's some pretty serious engineering going on in here as well. I mean, this stuff doesn't maintain itself magically. You've got to run it. And just as you have to think about, okay, well, how are we going to maintain our production environment or our QA environment, you also have to figure out how to maintain and run this new world of test automation that we're running. Because again, I think the trend is moving away from saying, oh, there's one big vendor, usually HP, that gives us all this stuff. And then, well, it's not great, but we can have one throat to choke, as they say. There's a very big variety of different tools we're using in the modern testing space. And so there's quite a lot more glue involved typically than we used to have. And I guess one of the consequences of that we're seeing is that, yeah, there's a bunch of people out there, people like BlazeMeter or Soasta or whatever, who are saying, yeah, we'll take that problem off your hands. So we're going to host all this stuff for you and run all that. But you then have to figure out, okay, so I'm now relying on a third party for some of my test capability. How do I make sure I integrate what comes out of that effectively, and how, it's an external service. It's also an external dependency. It's like a payment processor or something like that. I have to deal with that, downtimes and all that kind of stuff. If they're running a certain version of JMeter, can I tell them to use a specific other one or whatever? So what are the challenges that come with this brave new world of test automation? Well, I think one of them, I'm very much a fan of having lots and lots of different test tools because what we had previously, some of it was incredibly clunky, very expensive, very heavyweight, opaque, and so on. So I'm very pleased by this diversity. But the problem is that the more test tools you have, the harder it also gets to make sense of all the data that comes out of there. And we'll talk about that in much more detail later, because if we think about it, why do we run tests in the first place? Not so that I guess in some places it's so we can produce some kind of spreadsheet and tick a lot of boxes and say we're done. But in general, the real business reason to do this is to answer one single question. Is this stuff that we're delivering good enough to go live? And that generally requires you to look at all the data. And here's just a sample of some tools that we've used in projects, and we see people using 20 there or whatever. And there's way more out there. And of course, all have their own visualizations. They're different types of data. Performance data is not the same as functional and so on. Coverage also starts to become a little bit of a problem here. I mean, of course we all have code coverage tools, and they do the classic, oh, have I checked this particular line of my source code with a unit test? And that's fine, but again, if you think about the problem from a business perspective, I'm not interested whether 50 lines of source code have a unit test run against them or not. I'm interested in whether the key functional use cases like buying something or logging into my account or making a bank transfer or whatever those use cases happen to be actually still work, and whether the new ones that I've implemented also work. So it's not just technical coverage, it's really functional coverage that we're trying to figure out. And that's non-trivial, again, when we have lots of different tools, because it's not easy always to say, well, which test actually covers what? And different tools have different mechanisms that they do or do not support to make this possible. Tests also break. I could do another hand thing. Who's fixing a test failure right now? No. Yeah, and you don't want to spend a lot of time. The more tests you have, the more time you can be spending trying to figure out whether the test that just broke because there was an environment screw up, or the test data was corrupt, or because there's really a problem in the system. And so if we're not going to drown ourselves in additional work, we need to find a way to get this down, and that's really where good support for failure analysis becomes pretty important. And Jenkins has some nice things for certain types of tests in that area, but not necessarily in all of them. So, yeah, I've said some of this stuff already. I've asked some of these questions. Long story short, the more tests you have, the more infeasible it becomes in general to run them all the time. There's different schools of thought about this. I mean, Dave Farley, very prominent, testing and CD guy, co-wrote the continuous delivery book. He says, well, then you're just being lazy, right? If your system were too slow, you have to serve all your customers all the time. If your system were too slow, you just have to optimize it. If your tests are too slow, you should just optimize them. But Google takes a slightly different opinion, and Google says, no, not only does it take too long, it's actually too expensive. VMs cost money to run. So Google actually has a very powerful and complicated machine learning system that when they make a commit to their repo, supposedly, it can figure out which parts of the code are being affected, and it will tailor the tests that are run to match that particular commit, which is very smart and expensive to build. And I don't think I'm not going to give you a recipe for magically doing that and hire a bunch of data scientists. But we want to think about ways in which we can potentially achieve similar kind of things with Jenkins. But yeah, then you get into these questions. So which subset of tests am I running? What does that look like? Which tests matter? Which tests don't matter? I mean, more tests means you get a signal-to-noise problem. If you have 50,000 tests and 4 fail, well, percentage-wise, it looks brilliant. But if 43,000 tests of those are just getter-setter tests, then those 3 test failures suddenly start to look a lot different. All right. And yeah, we're at a Jenkins user conference. So of course, I'm sure a lot of you have tried to address some of these challenges if you have them with Jenkins. And it works in some cases, but it doesn't work in other cases. So you get a bit of Butler overstretch is what we call the term, and that can be a bit painful. So I think one of the things to learn with any tool, Jenkins or otherwise, is which things you can do well with a tool and which things are not so easy to do, and where it makes sense to try for something else. All right, let's look at the time. 20 minutes. So now I would like to talk a little bit, don't worry, we will get to the real deal, but this is an important scene setting phase, because in my experience, and my day job, we also sell continuous delivery enterprise tooling, so I get a lot of these discussions. A huge number of them, the focus is on execution of your pipeline. Because it's cool, and it's fun, and it's continuous delivery and DevOps, and you get kudos in your company if that's what you can do. And that's brilliant. But the point is, focusing on speed only is pretty risky, because there's nothing that will stop your continuous delivery initiative as dead as that. Well, not sure what as that meant, but never mind. If you happen to have a couple of high-profile production failures in a row. And the reality has always been that testing has always been the kind of like the forgotten stepchild, hiding behind the podium, because it's not glamorous, and it was those people over there, and we hate them because they give us all these defects back, and what are we going to do with these defects? We don't have any time, and so on and so forth. And that's just got to stop. And with some of the move quality left idea, or at least in principle that's stopping, of course, there's a lot of like, just like there's agile in name only, there's move quality left in name only. What's that? Emclino? I can't say it. But the point is, it's really, really essential. If you take one thing away, I would say, to your management, or if you're the manager yourself, testing, which is tantamount to quality and risk awareness. And tests by themselves, that's great, but what do they tell you? They're the key element that tells you about the quality of what you're shipping and the risk associated with it. That needs to be a first-class citizen in your CD initiative. Because CD is not just execution, CD is execution and analysis, which is tantamount to saying CD is speed plus quality. And that's when we start to get to a question I'm going to address at the end if we have time, which is, the execution part is well covered by pipeline orchestration, whether it's Jenkins workflow or whatever other tool you want to use for this, hours. But the other part is not so easy. And we're going to see what we can do in Jenkins to at least provide the right data, but I'm not sure whether it's at the moment the right tool to do excellent analysis. Anyway. Right, so now we're going to focus on, now we're getting to the bit that I discussed at the beginning where we say, before you can leverage like fast, efficient testing from Jenkins, you have to do some homework. This is the homework section. So this is stuff that you can do about your tests or in your test setup that you can do even if you're not running Jenkins, if you're just invoking them from scripts. But some of this is important in order to make the rest work. This is just a review. Most of you know this probably. So, and actually I'll talk a little bit about how this may or may not be slightly outdated in some sense, but in a lot of cases, you read about Cohn's pyramid, talking about the different tiers of testing, going from the technical more towards the user-facing, distribution, something like 70-20-10, or the numbers vary a little bit, and that you should sort of separate them out this way because some are fully automated, easy to write, the others are slightly more complex, they take longer to run, so UI tests might take 10 seconds per test just to boot up a browser or a browser mockup and so on. And then you get integration and performance tests even further down the line. And the reason they used to be further down the line and often still are is because they were even more expensive and limited resources. And you definitely didn't want to waste expensive time doing integration and performance testing if the other stuff was already broken. But I think some of this is maybe a little under or open for debate. And so, well, we've already said a few times testers are developers. And then the second thing, I think the second 101 point that I'd like to talk about a bit is that test code is production code in two ways. One, it's in terms of importance. If you start to rely on testing as being the thing that gives you a quality a risk output, it's got to be fast enough. You can't have broken windows over there. You'll have tech debt there as well, as you do in production code. But you can't let it lag behind too much. And you have to keep track of where are the hotspots, where are the bottlenecks, and so on. Because, yeah, if these tests start taking too long, switching them off probably isn't the right choice. Maybe it's easier to figure out why they're slow. So running tests as I was always prone to do on the cheapest, oldest laptop or desktop that you found. Oh, look, here it is, my test machine. That's not that's not going to help us very much given the amount of testing we want to do. The other thing about test code equaling production code is a sort of a variant of Conway's law that we've seen to be quite effective. It's like the Conway's law of testing. And what that means is that Conway's law says that your application code tends to be structured around departments, teams, functions. So you tend to find a reflection of your organization and the business problem to some extent in your source code. And extending that to testing is to say that you should, to some extent, also find a representation of your test system, of the system under test, rather, in your tests. And that's a little bit trivial to some extent, and a lot of you already do this, but at some point, you start with a one test, especially with like UI testing, and then you add more and more test cases, and more test cases, and more test cases, and it's pretty easy to develop this God test, this enormous test with I've seen unit tests with hundreds of different class or tests in them, and you start to lose this relationship between the stuff that you're testing and the stuff that is doing the testing, and that makes it very tricky to figure out, because this relationship also helps you identify which tests belong to which part of the code. When you refactor your application, you shouldn't just think about refactoring the tests themselves to still succeed, but if you're breaking apart a system into two components, you should also think about breaking apart the tests. Because at some point, if the divergence becomes too big, it's very difficult to understand, and especially to subset. To say, I only want to run the test for that particular component. Well, if that's 8 of the 70 tests in one enormous test, there's very few test tools that make it easy for you to do that. So, yeah, make sure that to some extent your test code mirrors your production code. That obviously becomes easier if we go with this developers or testers kind of thing, because it's much easier to do in a white box type scenario where people have access to the production code. And so I guess that's what we're talking about. The other thing is linking tests to use cases. So that's the third point that I think is very important to bear in mind. And what this means is think about, say, unit tests. The way your unit test class is named, it's named after the class that it's testing. That's fine, but that's a technical link. I can very easily, by looking at my test code, looking at the name of a test case, for instance, tell you which parts of my source code of my system are being tested. But if I were to ask you, oh, this particular feature that we wrote, like, I don't know, Acme 1, 2, 3, 4, 5 in Jira or Rally or whatever, which tests are related to that actually? That, in many cases, is a much more difficult question to answer. Some people start naming the tests after the Jira numbers and that kind of stuff, but that not great, because then you lose the other link. So what we need to do in order to be more efficient, also from Jenkins, is to find a way to create this link. And the challenge here a little bit is the different tools have different ways of doing this. That's really only one element of what I would call slicing and dicing. If we're going to be more efficient, and this is what I was saying about Google, they automatically slice and dice their overall test cases. But you want to be able to do this in many different ways. So we just discussed one particular way, linking the test to particular use cases. Linking tests to functional components is another slicing and dicing way, which is a little bit covered by the Conway's Law thing. But there are others, like linking tests to teams. You will see some reports a little bit later from one of the people some of these examples come from, where they want to compare the performance of different teams on a different day. Like, has one team introduced more regressions than another team or something like that? So think about, or other types of slicing and dicing, unreliable tests that take a long time to run, all these kind of things. They're all attributes that at some point or another we will want to drill down to. So we really need to think about ways in which we can label the tests that we write. And different tools, as I say, have different capabilities for them. Some support labeling as a native attribute. Some you have to do smart stuff like encoding it in names or metadata or something else. So it's not always trivial, but we can do that. And the last one is, and I think this is where we start to see a little bit of a difference between this and cone, radical parallelization. Now you want to fail faster than you were failing before. Fail fast is good, fail faster is better. This idea that you run, everybody knows the nightlies, we do work all day, and then at night the test machine crunches, and tomorrow we see whether what we wrote at 9 o'clock the day before was junk or not. That's like 24 hours worth of lag. Dave Farley just wrote a blog in which he says, in his view, 30 minutes is just about acceptable as feedback time for end-to-end testing. So he had a bunch of really smart developers when they built LMAX. That was his use case, the London Mercantile Asset Exchange. So they set up a custom test system to do that. They were averaging like 17 minutes end-to-end feedback. So he said that's what really helps you accelerate. But thinking that nightlies is still acceptable is maybe something we have to challenge a little bit. And in order to do that, we have to look at radical parallelization. I think I've said most of this already. Organizing tests based on the system under test. So this is a sort of example naming convention that you'll see an example of later. This is from Fitnessa in this particular case, but it applies to a couple of other ones as well, where we've split this kind of down, and the reason for sort of having this breadcrumb almost in the name is that you can then start to say things like, okay, I can chop it up at different bits. Like I could decide, first of all, to parallelize it by app, or to run only the tests for a specific app, simply by matching those test names, or those tests that match this convention. If I want to parallelize by use case, then I do that a little bit differently. Or, you know, in an extreme case, I might say I want to run each test case on its own Docker container, for instance, which you can also do with this kind of setup. Test dependencies obviously make all this parallelization difficult rather. So a clear guideline, tests should not depend on other tests. It's very tempting, especially with like complicated test fixtures, to set up tests where you say, okay, well, you know, we're going to insert a record in the database, then we're going to check if it's there, then we're going to add another one, then we're going to delete the first one, then we're going to do the other one, we're going to do that all together. And that's fine, but this is very highly coupled now. And setting, I mean, there is a bit of a trade-off here in the sense that, of course, you also don't want to have that terrible, like, I have to set up 800 mocks in order to test one thing in my unit test, and I don't want to copy this 800 lines of mock code into every single test. Well, how would you fix that in production code? You would fix it by factoring it out. Having a good fixture setup system is a very essential part of making this possible. So, you know, you may have to think of, again, Dave Farley talks about having a custom DSL for this, but some tools have pretty good support for this. Think about factoring your fixtures in such a way that it's very easy to set up a fixture for every test. May not be possible, but try and go towards that. And of course, part of this is not just the way you define the fixture. Sometimes the systems are very hard to set up as well. You know, if it takes 8 hours to prepare a system because you've got to take like a snapshot of production data or whatever and then load it over a modem, yeah, then you're going to have a problem doing this. So then you have to start thinking about whether there's not another way in which you can do this. I said this already, keeping it manageable, focusing on functional, not technical coverage, so be aware of how many use cases you are covering rather than how many lines of code. And also if you look at say you have 40 user stories and 400 tests, well, that means an average of 10 tests per story. But is that the right thing to do? Like, no, you shouldn't probably have 10 tests per story. You should have more tests for those user stories that are more important. Like if buying from the shopping cart is the important thing, you need to have more tests for that. So this is a metric that you might look at, like the distribution of your test cases over the important use cases, which implies that you actually can rank the use cases by importance, which I hope you can all do, because you know, otherwise it's very difficult to know what's really relevant about your system and what isn't. Don't get me wrong, I probably couldn't even do it today. I'm the VP of products. I should be able to do this. But you know, that's not an easy thing to do, of course. Make sure you keep a lot of metrics about your tests. Jenkins will help you get some of these. Obviously, the number of tests that you run, but also the number of tests that have not passed or failed in a certain time. Flaky tests are the opposite. That's tests that keep going on and off and on and off and on and off. So they're a problem because they indicate either that the test fixture is broken or that, you know, there's something it's very seldom that a flaky test is caused by actual developer commits breaking something, then fixing it, then breaking it, then fixing it, then breaking it, then fixing it. Much more often it's caused by some kind of lack of reliability in the setup or some random like race condition. So flaky tests are good to know about because they contribute noise. But number of tests that have not passed or failed in like 2,000 test runs, that's also noise. Right? That's not signal. That's not telling you anything really useful at this particular point in time. That just lets you go, oh, good, we've got 2,000 passing tests. Yeah, great. They've been passing since forever. So is that not distracting you from where the real stuff is happening? How long tests are taking and so on. So I talked about all this, you know, label, known issues. Known issues, another nice one. That's another one that's not, so we'll talk about a challenge with Jenkins in a second. Oh, I've got to accelerate. If something is a broken test but you know about it, yeah, then okay, but you might accept that. Right, now we get to Jenkins. Tilt the pyramid. Basically, this is testing, sort of Jenkins testing 101. I'm pretty sure all of you, except those who are brand new to this, do this already. You take this pyramid, you turn it around, and then you use that to slice up your Jenkins jobs. All right, so you do the unit tests in one job, and then the service level tests maybe in another job, and then the UI tests later. And that's pretty easy, and we'll talk about maybe a next step from that in a second, but that's the first obvious and natural thing to do. And start simple, so do that. Make sure, of course, when you're doing this, that you know that you're testing the right stuff, and that it's the same stuff that you're testing in each of these tests that you run. There's nothing quite as frustrating talking about minimizing mean time to repair, to discover that you've just sunk hours into trying to figure out why this test is failing when it's not the version of the code that you should have been testing in the first place. So use, obviously repositories and fingerprinting. Jenkins has nice support for fingerprinting artifacts to make sure that you can be certain that the system under test is the same in all your jobs. Try not to run too many tests in the same job. It's difficult because back in the day when creating a job in Jenkins there wasn't much automation support. Having 10,000 jobs was an enormous pain, and if something changed, it was to try and go into all these jobs and edit them. Jenkins has a pretty powerful command line interface. It has the job DSL, now it has the workflow plugin. It has a lot of things that make management of multiple jobs a lot easier. So if you can, try to consider not just different test tools, but also different test platforms, like if you're doing like a matrix test, for instance. Split that up into separate jobs, either by doing that by hand, if you like, or using the multi-job plugin, which is the sort of canonical matrix testing. It's getting some competition now, obviously, from the workflow plugin or from the job DSL. But yeah, so copy artifact is the thing for the fingerprints. Multi-job would be for the splitting stuff up into different jobs. Workflow is another alternative for that. And of course, that allows you to coordinate these. It's pretty obvious stuff. Try to keep your Jenkins jobs sane and simple. And one of the things that this means, certainly in my view, try to avoid having complicated run this script tasks in Jenkins. They're not great to manage. Yes, Jenkins has a whole bunch, it's got better over time in terms of how much version control you can do and history and all that kind of stuff with your Jenkins jobs. But really, having complicated like scripts in little windows in text boxes that you edit in Jenkins or copy paste into like Notepad++ or whatever, yeah, that's not the way to go, right? If you're going to run scripts, either use plugins to invoke the test tools directly, or have invoker scripts that you store in source control. And then your Jenkins invocations should be no more complicated than check out the appropriate version of that particular script and invoke it. Make sure the scripts are parameterized, right? Don't assume, things like, if we're putting them under source control, which version of the scripts are we running? The current one, but we should be trying to run the same version throughout our pipeline. So this will be one of those parameters that we end up passing through the pipeline. Not just the version of the code to run, but also the version of the test scripts that we should be running. Other parameters, obviously things like these labels. If we're going to run a filter and only run a subset, we have to make sure that we can pass that in. So think from the beginning, these invoker scripts need to support the options that the underlying test tools support. That's point 6, actually, as I've just said. And labels, so Cucumber and Fitness and some other tools support labels natively. Otherwise, as you saw, you can get a bit more creative with naming of tests. That's another pretty common way of doing this, because most of the XUnit type tests give you an option to say, I want to run a subset of tests by name, and they even give you like regex match options, so you can use that as a kind of filtering scheme for your tests. So yeah, this is the kind of standard stuff that you would get if you had that. Yeah, so here we probably have some unit tests within the build. Yes, that's probably not too stupid. If your unit tests take a long time, I think it's worth arguing that you might even want to take those out of there. I've run a whole ton of builds where the unit test took up about half the runtime of the build itself. So why not put them in parallel with a deployment, for instance? Of course, if a deployment is like a $10,000 job that takes 12 people 5 hours to do, you're not going to do that. But as we'll see, I think we're moving away from that a little bit. So one challenge with this that we'll talk about in a sec is the scattered result qualification. But before I get to that, think radical parallelization. Like the mindset we had by force, because environments were expensive and took a long time and very brittle and were used by all these different teams. Yeah, it made sense to push all the environment-specific tests way to the end because they were so risky and cost and time-intensive to set up. But we're in an era of dirt cheap throwaway environments now. And that allows you to think about much more parallelization than you may have thought previously possible. And if you manage to make sure that your jobs don't depend on each other either, that's the Jenkins corollary of the tests not depending on each other, then you can maybe even think about a test setup like this. And I should add right now, I mean, from what we've just discussed, maybe even, you put your unit tests up here too, or your code quality tests or whatever. So, we can do more parallelization than we think, I think. There was another point here. Yeah, test jobs are the eyes and ears of your pipeline. Like, I've met many a Jenkins admin who's incredibly, Jenkins has to be smooth and the plugin stuff has to work really well. And I want to know the configuration of all my jobs, blah, 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 blah. Yeah, that's great. But the stuff that really matters in Jenkins is really your test results. So those jobs have to be optimized much more than the rest. Like the other ones, okay, but these are really critical that they work nicely and give you the data that you need. The challenge that I was going to talk about for the last couple of minutes before we get to some questions, hopefully, is this scattered result problem. Right? This is the Jenkins workflow view, if you've seen it. And it shows you, as I said, great for execution. Now you tell me when you look at this UI, how good is it? Well, I don't know. And I think that's the simple answer. I mean, yes, I can give you a sort of traffic light answer in the sense that, oh, look, the build number 108 didn't make it to the deploy phase, so something must have gone wrong. But that's a very, very high level, very black and white kind of answer. So the point is that real go, no-go decisions are non-trivial. Yeah, it's not like, oh, no tests are failing, or very, very seldom. It's like, oh, we're okay with 5% failing tests. Or it's, well, we just don't want we don't want it to get significantly worse. Or we want it to fail, well, we want everything to succeed except this list of tests over here that we've already accepted are going to fail. And that requires historical context, right? You can't answer some of these questions without knowing how the same overall suite of tests ran the previous time. And it also requires context across different test tools. No regressions doesn't just mean no regressions in the unit tests. It means no regressions across unit tests, functional tests, performance tests, and so on and so forth. Plus, you want to also figure out how to improve over time, like where are the tests that are slow, where are the tests that are flaky, where are the tests that take a long time to set up, and so on. So executing tests from Jenkins is great, but you end up with like a lot of test results coming in a lot of different places in your pipeline, and every plugin seems to have its own flavor of how it wants to visualize them. So there's not really much consistency in terms of the viewing, the analysis experience. Some plugins have a pretty nice historic view, others don't. Like the Gatling plugin's pretty okay. Some of the code quality plugins, they do it totally differently with this weird mountain landscape thing that I'm sure you all know. And yeah, typically you'll have those two in different jobs, so it's very difficult to put them together. Another slight challenge is that pass unstable fail is a little bit too coarse. It doesn't tell you, there's no way of encoding in that. With it passed, we did have some test failures, but we accepted those. You could say that that's passed, but that it's still maybe something that I, as a business consumer or as the development manager, would want to know. Like, I'd rather have no test failures. Pass with known test failures is acceptable, but it's something different. So this ultimate question is a little bit difficult to answer, and the reason I'm spending so much time in this presentation is mainly because I want you to think about this and to give you some ideas about what you can do and what we've seen people do with a sort of homebrew solution, because unfortunately for now, I'm not aware of a great out-of-the-box, oh look, you install this plugin in Jenkins and magically it does it all for you. Who knows? I'm sure the smart guys from CloudBees have some interesting stuff coming in the pipeline for the workflow plugin, but not right now as far as I'm aware. So these are just some quick examples which I'll just run through because otherwise I'll be way over time. This is this naming convention stuff that I was talking about. These are real life examples. They started out with one, then they decided to split it up. So they did functional splitting in our web shop. Those are all in a different structure. But because they split the web shop into two architectural components, they didn't have all the web shop suite tests in one place. They had overarching test suites for each of the two different components. So that allowed them to stick with this Conway's Law thing. But within those, they had subsets of the web shop suite stuff. And this allowed them they actually moved away from nightlies finally. This allowed them to say things like, initially they ran them all from one system, and then that took far too long, so they decided to split up. Web shop ran on one Jenkins slave, others ran on another Jenkins slave, and then they got to the point where they had to split up the business account suite, and so on. Their pipeline looks a little bit like this. So you can see pretty standard, nothing too crazy going on here. Some interesting points in the sense of what I was talking about. They still have the sort of linear structure here at the beginning. So the unit tests are in a separate job, but they are happening way before we get to the smoke tests. And on the next page, this is the one I try to squeeze on here, all the different tests that they run here. So they have after the kind of basic code validation phase, they've got these dedicated team environments in which they run 3 types of tests in parallel. They run these security tests. They run their code quality tests pretty late because they take a long time to run. But you know, they're perfectly happy to move to this stage because they can also accept certain levels of quality defects. So they don't want to like wait all that time before getting the system tests out of the way. And as you can see, they run a whole bunch of different types of test tools as well, with Jenkins coordinating this stuff. And then they get into these end-to-end, they call them chain environments, I don't know why. They get into these end-to-end environments once they've run all these particular tests. So yeah, you can see some level of parallelization. You can see it's not finished yet. You know, there's still more work to be done here. It's kind of a bit of a work in progress. You can see the use of dedicated environments here as well. This is some of the Homebrew stuff that they do to split up the results. So they take all the results and then they chop them up based on, I can't remember what it is. I'm not going to go through the source code here, but they structure, they get the names of where these results are from, and then they annotate them with teams and tags and things like that, so that they can then report on them in some of their custom reporting. So you can see here, for instance, they've annotated all these tests by team, and what that allows them to do. So this is basically, they post-process the results. Jenkins invokes the tool. And then they have some post-processing that goes on, and then it spits out a link in their Jenkins job that takes them to this dashboard. And here they see, obviously they have this priority concept, and you know, there's some deep link here. But from this team information that they've added, this is where the labeling comes in again. You can see that they're now comparing. It's pretty brutal, I think, actually, to some extent. I don't know what happens to the teams that do badly. Maybe I don't want to know. But yeah, they compare teams against each other. And this is, again, some custom reporting that they've built. So, you know, I'd love to see a plugin that did this out of the box. But I think it's important just to point out that you can think about all the execution stuff. There's some pretty nice stuff you can do there. But if you manage to annotate and label your tests correctly, you can also think about these kind of reports. You can also see that they label their results by different categories as well. So it's beyond pass-fail. They have known issue as a category that they've added, which is like, okay, it failed, but it's not such a big deal. Of course, if one team ends up like some of these teams here have like what is it, 2BC and 3A, have a lot of known issues, that's maybe a different issue that you might want to tackle. All right, in summary, oh God, I'm already over. So no time for questions, you'll have to come. Testing automation, test the developers, structure and annotate your tests, think about Conway's law also for testing, parallelize if you can, but probably you can. With modern automation technology around environments. For Jenkins, keep the job simple and independent. Make sure you track your system under test. That's just basic fingerprinting stuff. Try to avoid complicated invoking your test tools. Parameterize all your test invocations so you can do some of this labeling, or so you can run a subset. You can say run only the test for this team, for instance. Parallelize, optimize. Remember, CD is not just speed and execution, it's also quality and analysis. Still a tough challenge making sense of the results, but we need to do this in order to figure out how to address real-world go, no-go decisions. That's that last bullet point. Thank you very much.